Okay, so hello, welcome. This is an EAA session. It's just a shakedown session of the equipment so far. So what we've got is a CPC-800 outside on my decking. Just hold on, let me show you what I've got. Oh, there you go. So this is my CPC-800. It's just outside of the decking. I'm on the Isle of Wight, which is an island off the south coast of England. It's just gone into like civil twilight really. But the stars are out and I've just aligned the scope. So this is the main scope. I'll show you the back what we've got here. So we've got an Altair Astro 294C colour camera. There's an F6.3 focal reducer on there. And that's a Baader Planetarium Prism, T2 Prism, so that I can attach the T2 spacers to get the right spacing here. The spacing we've got tonight is F6.39, which I'm finding was better than F6.3. I think it depends on the scope. The other thing we've got here obviously is a Celestron Focuser. You'll notice there are two USB leads coming off here. This is a USB 3 lead. And this one down here is a USB 2, and that goes into the focuser and then goes down into the telescope and controls the telescope as well. The telescope's quite old, 13, 14 years old now I think, and when I went into EAA about 2 years ago, it was not going to change. I wasn't going to buy a new telescope. So I ended up buying the camera, and I ended up buying the focal reducer and obviously the prism. I was just using a simple 1 1/4 inch push prism, but I think this is better for actually keeping everything nice and stable. So that's the telescope. This is the software we're running tonight. So we have Stellarium, which is the Planetarium program I'm using right now. This is CPWI, which is controlling the telescope, and I've just finished the alignment. So I'm going to get rid of that for a second, and we're going to bring up Astro Planner. Let me pin that to the top, and let me pin that to the top. Oh, have we just lost? Oh no, sorry, that was my fault. And let's get the view from outside. So we're currently, hold on a second, before we start doing that we better bring up the remote server, and we're going to connect the telescope. Oops, we've got the prompt tonight. There you go, so we're going to connect to the telescope, and there we go, and there it comes flying down. I know this is a bit of a kitchen sink setup, so we've got nearly everything that you'd need on one screen. So if you have a 4K monitor, then you'll see it. I'm afraid if you've got an HD monitor, some of this text is not going to be readable, but we're going to sort that out in another session. But so we've connected. So what we have here is that this is the camera. This is the SharpCap 4 running on the laptop outside. CPWI, which you saw a minute ago, is also running on the laptop, and then Stellarium and Astro Planner, they're running locally on the desktop that I'm on right now. And we've got something here. We've got the telescope thing here. Dear, where should we put it? Over here somewhere. I don't know if we're going to need it, so we'll leave it where it is. So this is our setup. Everything is really going to be controlled from Astro Planner. This will show us what we expect to see, and this is the live view right now. So what we're going to do first of all is maybe not look at the news. We are going to look at an object, and I think the first object we're going to look at, because it's quite close, is going to be M3. So if I move to M3, I've got some scripts that run and from Astro Planner, and they just synchronize with the view with Stellarium, And also what I can do is I can generate a banner where it says the EA Celestron will change hopefully to, there you go, to M3, which is what we're looking at right now. So we're going to slew over to M3, I think. Yeah, it can actually cause damage, he's absolutely right. Let's come out so we can see where we're coming from. There we go. So here's the CPC-800 coming now. Let's see how close we are to M3, which is a globular cluster. As it says on the screen, it's 33,000 light years away. And as you see, we've put it dead center onto our screen. What we're going to do is turn the reticle off. Now we're only walking on, this is 1/4 of a second exposures. So that's not too bad. I'm going to move up to 4 seconds. And there's our 4-second exposure of it. I don't think we're actually focused. So let's go back to 1 second exposure. Yeah. So what I've got here is Windows Power Toys. Sorry, Windows Power Toys allow me to pin windows on top of other windows, which is the reason I can pin the laptop and the data and the desktop applications around each other without affecting them. So I'm just going to do a multi-star because that is, I don't think, anywhere near a focus. Let's come. We'll go out 50 and see what we see. I think that got worse, so we're going to go in 50. I'm going to go in 50 again. In 50. Oh, it's definitely getting worse. Out 50. Out 50. I don't think I was giving it time to settle. That was my real problem. Out 50. Let's make it out 15. Out 15. I think I quite like that. I think we'll stick with that. Okay, so the great thing is that my little script that runs and puts the banner up that you see at the top of the screen also puts it on the clipboard, so I can just paste it into here if I want to do a capture, which is what I'm going to do now. So now we've got 1 second sorted out. I'm going to go back to 4-second exposure, and I'm going to start doing a live stack, I think. Let's have a look. That looks good. Let's turn off the stretch on that. Let's reset everything here. Let's do a stretch. Wow, even brought the white level up. Right, so that's slightly too much, so let's bring that back down. So this is, oh, we're dithering, yeah. Okay, so I'll explain what we're doing here. So we are, tonight, we are not running any darks and we're not running any flats. What we're doing is we're using the hot pixel removal as the subtract dark over here. You'll see it over here. We're not applying a flat. We are using dithering, so every 4 frames it will dither, and what a dither does is it moves the telescope in a kind of random walk, and that smears the noise across different pixels and it averages itself out, so you lose noise from the image as well. And then we're not using flats, but we are using background subtraction. We're using gradient removal. Now remember, we're doing EAA, we're not doing astrophotography, because those guys spend absolutely hours collecting the data and processing the data. Much respect to them for that, because they end up with beautiful images. I'm snapping. If I take a picture, it's just a snapshot. It's a postcard just to remember what I saw. What I'm really doing is visually looking at the image, and I can do that right now. So I can zoom in to my globular cluster and see this compact ball of stars that's 33,000 light years away. In fact, I've got another image already, actually. Hold on a second to see if I can show you my image here. Let's fit to window. So this is an image from another night we've got stored in Astro Planner. So that's good. Let's bring Stellarium back up, because with Stellarium we can see what we see here. So this is, if we look at this is the DSS view. That's a picture of it. This is the DSS view of it. Nice. So it's magnitude 6.3. Let's come out a bit more. Oh, sorry, I've got to pin that if I'm going to leave it there. So if I use Power Tools, I can just use the thing and pin that to the whole thing. If I use the control button and the scroll wheel, I can come out. So we're dithering right now. I'm at 50% zoom right now. Should we see if the colours are right? That's not right at all. Let's reset back to where we were, because that looks a bit better. So what we're going to do, I'm going to zoom in actually on the histogram so I can get this slightly better. So we have a blue, a green and a red, and there's a great video actually. If you're on Cloudy Nights, there's a great video that shows you how to balance this, and the way it is you leave the green alone and we bring in, I'm going to bring in the blue so it overlaps onto the green, and then I'm going to bring it the red channel and I'm going to put it over the top. Now what I've done is I clicked on that slider and I'm using the arrow keys to move it gently into place. It's still a bit green, isn't it really? Let's just boost the blue a bit. Yeah, that's okay. So here's our globular cluster. So we have 35 frames stacked, 14 have been ignored. The main reason they've been ignored is because it's dithering. So, and when it dithers, it does a faster frame rate. I think it drops down to 2 seconds. We might see it in a second actually. If we go into the log, let's see what we can see on the log. I come down to the bottom, usually jumps down to the bottom. There you go. So there we go. So now we are dithering. So it speeds up. Oh, we've completed it. It was that quick. So it speeds up the exposure, the subs, from 4 seconds that we're running at to 2 seconds. And now I'm going to start moving this black level. I like to have it up there. Let's just start stretching this image a bit more to get. Now let me show you if I stretch it completely. Now what you'll see over here, so these bits here, these are dust. This is dust on the sensor or somewhere in the optical system that's casting a shadow. You'll also notice the corners are darker than this brighter center, and that's because I'm not using flats. But I'm going to balance it off so I can get a fairly decent view. On YouTube I've got to be a little bit careful, I think. Apparently, so I'm going to make it a little bit better. There you go. So we've got 50 stacks. So this is a 3-minute 20 stack now of M3. This is the reason I got into EAA. So I was a visual astronomer all my life since I was a very young person, and now I'm a much older person. And EAA had to satisfy 2 things that I wanted to do. So I'll explain that in a second, why I've got some red bars. Oh, you can't see them. There they are. They're just popping out now from behind me. There you go, I'm back to green. So I wanted 2 things. One is I wanted to see more. I sat at an eyepiece and I had frozen my legs off, and 5 more minutes under the stars, seeing grey smudges. And what I wanted to see was 3 more things. I wanted to see colour, I wanted to see more structure, more detail, and I wanted to see fainter objects. And EAA does all of that for you. From the time I got my camera, which is about 2 and a bit years away now, well, nearly 2.5 years ago, and built the system up, I've seen things that I haven't seen in my entire life, sat at the telescope looking through an eyepiece, looking through the same scope. And I suppose that's quite important. All of my observations recently from the last 14 years were done with this scope, and so it's very easy to compare and go, wow, there is a great difference of what I can see. And we're coming up to 4 minutes now. I can stretch this a little bit more, I reckon, now. The great thing, sorry, I better explain what these red lines were. So this is where I'm using a filter. So if the atmosphere gets too unstable, it's measuring the size of the stars. And if they go above my limit, which is currently 5.61, which was just a random thing I selected to get quite close to what I was seeing, it throws away the frame, because the frame is not what I was wanting. So it doesn't include it in the stack that you're seeing here. Sorry, I just went to the wrong one. The same thing applies to brightness. So if this is a bit weird actually. Oh, I'm not filtering on brightness. There you go, I'll filter on it now. So if this drops below a certain level, quite a low level actually, then it will stop. And that happens when, say, a cloud goes across. So then it will stop stacking until the cloud disappears, and you'll see it dip down in brightness, and then you'll see it come back up again. So that's really good. What was I saying? So yes, so that was my main thing. See more, see colour, see structure. And my second thing was, don't sit outside and freeze. So that's the reason I'm inside the office right now, watching what my telescope is doing on the outside. Now, in order to do that, I needed to have the focuser, the motor focuser on it. And I need to put a laptop out there to run it, and I use CPWI to run the scope. And that's what these pieces of software, Stellarium and Astro are talking to. And before I even went on air, what I did was that I aligned my scope with some stars. I modelled about 6 stars. You don't need to do that many, but I kind of enjoy it. A bit weird, lining up your stars. And I use things called plate solving, which takes a picture of the stars and then compares it to a database, matches it, and then moves it to where it should be, rather than where the telescope is first lined up. Because obviously when I throw that on the decking, I roughly level it, I roughly point it north, and then I say go to a star, and it's obviously going to be off. In fact, the first one today was about 2 degrees off. So we're at 5 minutes 20, and I think we've got a quite good image here of M3 globular cluster, 33,000 light years away. And I think that's it. So what I do now is maybe take a snapshot. So I take save exactly as seen, and I've saved that. In fact, if I want to show it to you, show the image that's just been pulled up. Here it is. Oh, it's because it's behind there. Oh, I can't get it. Sorry, I've pinned everything, so it's all a bit. Oh, I'll close it down. I'll get a second, but that's oh, it really doesn't want to close. There it does. So it's just taken a snapshot of it, and now I can say that's been done. Now I could go into my software and I could mark it as being observed and things, but I'm not going to do that tonight. So let's pause that. And oh, actually, no. Let's resume a second. Let me show you another feature, great feature of SharpCap, and that is that I can do, and this is the plate solving I was just telling you about, is I can annotate this image. So it's doing a plate solve now, so it's taking the last picture and it's finding where it is. Hold on, I'm dithering. And it's hopefully going to annotate this display. Let me try again nearby. here we go. So I'm going to plate solve this. And how many dose sources? That's more than enough. There you go. So not only in this image, as you see, there's the globular cluster. If I zoom in, you'll also see that there is a galaxy. That's a 17.1 magnitude galaxy, and it's right. Oh, gone too far. It's right there. And there was another one up here, wasn't there? Is that 17.18? Don't see anything in that one. Let's come out a bit more so you can see what we're going to do. Can't really see any more. There did seem to be one there. But that's the great thing about SharpCap, is that we can zoom in, we can pan around, and we can also annotate our images to see what other objects are within this area of the sky. And they're all here. So if I click on here, that's the globular cluster, that's the next, it's in yellow usually. Oh, there it is, PGC. Up there, another galaxy. I think that was the galaxy we saw, the 17.1 right there, PGC 1829661. No idea where that is in the world, as in how far away it is, but magnitude 17.1. And that's another important thing, is that my telescope visually, Celestron say, is magnitude 14.2 or something. And here I am on just past, and it's not even into, oh, it says now, it's into nautical 2318. Yeah, so it's just gone into nautical twilight, and we've got a magnitude 17.1 galaxy visible, and that's seeing further. So we see more structure, we see colour, which we'll see later on, and we see further. We see much further than 17.1 as well with an 8-inch scope, so that's all good. So let's pause that. I'm going to clear it, pause it again, get rid of live stack, and we go back to our 1 second kind of, this is a kind of find and frame mode, and even in 1 second you can see quite happily that we have our little globular cluster right there now. What I'm going to do actually, I'm thinking about, if I use my script I can just make, hopefully this will work, go to M51. Yeah, there you go. So M51 is, well, let's see what it is. It's a galaxy. I'll change the banner. So it's 31 million light years away, so it's a different kettle of fish, this, to the globular cluster that is with, it's orbiting, the globular cluster orbits around our galaxy, while this is part of the local group still, the Whirlpool galaxy, M51, but it is 31 million light years away, and it's an interacting galaxy. As you see here, we've got these kind of two kind of interacting together in this gravitational dance, which is quite beautiful. Here's a picture I took before down here, but let's go over to it. Sorry, so if we slew to M51, let's come out so we can see where we're going. Here we come. We're coming down, and we've landed on M51. And straight away you can see the bright core. Well, I can see a bright core. It's a bright core right there where my mouse cursor is. So I'm just going to delete what was in there before, paste in my new M51 Whirlpool, and we'll change our, what should we do it at? Let's try 6 seconds, just for the laugh of it, for the crack. I mean, it should be all right. I mean, like you say, I mean, we can already see the core already. Oh, look, if I do that, I can almost see the start of the spiral structure of it. I'm going to go 6 seconds for this. Just give it a try. So we're live stacking at 6 seconds. Let me get rid of the stretch on here. Let's reset that back down. Take the zoom off. Oh, we have a very high Oh, that's very high. Let me just take that off a second, see what we got. Let's do an auto stretch on it. Yeah, stars are a bit blurry. I'm going to go with it. Let's just go with it. I'm not going to mess around too much. But as you see, look, I'm on 3 frames already, and I haven't done anything. And if I bring this stretch up a bit, you can already see the spiral arm structure. Oh, well there's a difference, as you see, between the 2 images in Stellarium. That's because my Schmidt switches. It inverts the left to right. So if I just do that in my little planetarium, and I can make it look the same. Let's bring the red down. And let's bring the blue up. Excellent. Got quite a bit of noise. Because, I mean, it's not dark. That's the thing. It's not really dark when we're looking at galaxies. So we've got 10 frames recorded, 60 seconds of data so far has been recorded. And as you see, we can see the structure. If I zoom in a bit more. So we've got the structure of this one arm coming out here, going all the way around. Then we've got this arm coming out of the outside up here. Then you see that this arm goes all the way out to here, which is the other galaxy, which is interacting with it. Stretch it up a bit. Got some hot pixels there. Here, these red little pixels here, you might not be able to see them. There's some structure here starting to form, which is, if I zoom in here, there's a structure, it's these kind of like bars that go across between, or they appear to go across. I think it's another spiral arm coming out in between, and it's in between here. But you also notice that as well as the stars, there's also these fuzzy objects. This one here, for example, this one here, and all this up here. And I think these are H2 regions of star forming happening in M51, but I'm not 100% sure. So but that also looks like it's going on here. And if I come out a bit more now, so we don't have so much noise, you can see we are making an image. So we've got 2 minutes 30 seconds now of data. I think this is a bit high. I think I should have refocused when I got here, but I'm not that perturbed by this, because I'm seeing what I want to see. I'm seeing these regions, which I believe are star-forming regions in a galaxy that's 31 million light years away. The light left this place 31 million years ago, before humanity was a twinkle in the eye of evolution. But it's looking good. Maybe we can find out some more information. So I like Stellarium. Stellarium is the Planetarium program I'm using right now. As I said, I wrote a script. Well, I've got a couple of scripts that allow this to drive the Stellarium. I didn't like the way Astroplanner was using, the way it's actually built in, but I think I've turned it off. But there was a way on the menu that you could center an external application, but I've turned it off. Because I prefer my way of doing it, because what my way does as well is it does a few other things I can put into the script, which is what makes Astroplanner a really, really great tool for planning. but also I use it to drive the rest of these applications, and obviously the top, whoops, I won't go that way. No, where should I go? The top bar up there somewhere where it says M51 Whirlpool Galaxy, 31 million light years type galaxy. So its AstroPlanner is driving that to a file which OBS, which is streaming this to the internet, is actually putting up there now. But I love AstroPlanner. I mean, look, I'm connected to my telescope. I've got all my objects here. I know I've got images of these ones which I've done before. I can put observation notes in and things like that, but there we go. We're up to 4 minutes now, and we're not really balanced very well. Let's see if we can bring it down there a bit. I think we might have stretched this a little bit too much. Let's have a... Oh, I'm going to stretch it up a bit more because I'm just crazy like that, but... Yeah, I think that's okay. We'll just zoom in a bit more actually on there. I mean, I should have, like I said, I think I should have focused a bit more on this, but we're going to let this build up. I'm not very patient when it comes to this, so I'm not going to do fast, not going to do very long exposures. We're at 6 seconds now. I do go, 12, 15 seconds, but that's about it per sub. And I usually spend about 10 minutes on a subject, just looking at it. However, it depends on the subject. So if I think there's some interesting stuff that we could find out about, for example, M51. Oh, I didn't select the object, did I? Sorry about that. I just assumed it wasn't really selected. There you go. So let's look at M51. There we go. Grand design spiral galaxy. 3'2" active galaxy nucleus. 31 million light years from Earth, which we already knew. Charles Messier again. Rossi. Lots of great stuff here. Observed in various wavelengths. That's quite nice, isn't it? Oh wow, planet candidate. Extraordinary. But we can always just sit, and that's what I was going to say, is that even though it might be like 10 minutes that I normally sit and watch, or less, it all depends on the object, of course. But sometimes you just get engrossed reading up about the object and then going to see what you can see. And then you might be there and all of a sudden you suddenly realise that you've been stacking for 30 minutes. And of course I take a snapshot at the end of that, because as I put more and more frames on, I do reduce the noise. So it does help. You see, now here you see where the you can't see. Let me just move my screen out of the way. Do you see how my brightness has gone down, and my brightness filter now is triggered, and it's stopped these 4 frames from being stacked, because obviously a piece of cloud went across and took that. Let's see if the next frame is any good. Yeah, so I put myself back down there in the corner. So that's okay. Well, we're still going. Now, there are certain tools inside SharpCap that we can use that might improve the sight. And if we go to enhancement and we use a Viner deconvolution, it would darken everything. As you see, it darkens the noise, but it also sharpens. And then we can adjust it. So we might go 6.5 and go, that's, well, maybe not. Let's go 8, see if that helps. Made it a bit brighter. The more, the bigger the value I put on here, the more it's going to bring in this kind of artifacts of this noise around the image, but it's not too bad. It takes a lot of processing power, so you see my stacking time and rendering time. Oh, actually they've gone right down again now. Am I dithering? I don't know if I'm dithering or not. No, I just finished dithering. It can take a bit of time. So up where I'm using a 6-second exposure, the laptop has actually got the power to do it. It's like 3 seconds, isn't it? To do all the details, and then the next image comes in 3 seconds later. So it's 75%. If I just do the full view that the sensor gives, that's how big an area we've got. And let's just zoom in so we're... Oh, it's 106%. We better not go past 100%, I don't think. But you could do. It's up to you, of course. And you can see now it's starting to join up here with this galaxy. And if you leave it long enough, you can see there's a swirls up here, and there's swirls of stars all the way around this area as well. Well, here on the Planetarium program, you can see that it's... And you can start seeing these holes on the image. It's definitely on the image down here. But you'll start to see it. In fact, if I stretch it up, let's see if we can... It's not going to do it. Now you can see all the artifacts put in by the noise, but there's a faint patch here, and there's a kind of a dark spot here, and there's a dark spot here I can see on my image. It's very hard for you to see, but maybe you can see it. There's a dark plot there and a dark here, and you can see that this extends out further, just like it does on the Planetarium program. And if you see it, it will come down here, and this will disappear up. And this is still part over here. So that area there is actually this area here, not the one with the galaxy on it, but oops, the one with the H2 region I was aiming for. This H2 region here is this H2 region here, which is good. What are we on? 8 minutes. There are 2 galaxies here. There's a spiral galaxy. Let's zoom in and I'll show you the spiral. So it looks like an edge-on spiral galaxy here, and then more of an is it elliptical galaxy over this way? I think it is. Oh, it doesn't like jumping that far. Look, I mean, it's hard to tell, isn't it, on there? What is it? Oh, it doesn't say even. Let's come out of here a second. So this bit here is the edge-on galaxy, and this bit here I think is some elliptical galaxy. And so you can see them in the image, and they're forming up nicely as well. So IC4277 is, it do not say. Why don't we see if there's any information on that? No, doesn't appear in, what was the other one? IC, doesn't say anything about that one either. So we'll just have a little look, see if it's got anything on Wikipedia on that. No. So what we'll do as well, we'll just do a plate solve and see if we can, this has got any more information. Maybe it's in the PGC catalogue as well as the IC. There we go. So yeah, it doesn't give me any. Oh, that gives me a magnification. Oh, that gives me a magnitude of 17.8 for the elliptical, and it doesn't give me one for the edge-on spiral by the looks of it there. But we've got NGC 505 is one galaxy, and then you've got M51, the Whirlpool, which is the next. Let's come on out, see if there's any more. Oh, there's one up here, another IC galaxy, and there's one over right on the edge of the screen. these black lines that we're seeing down the edge, actually if I just pull it down it'd be easier. This black line that you can see, that's where it's rotating around and it's losing that. So that star was particularly bright, so it remains, but the rest of it goes. Let me go back to auto, take it out. There we go. So we've got M51, NGC 5195, NGC, oh, what have we got? 5195, 5194. PGC's over there. That's the IC. Oh, that one there. Yeah, magnitude 17.8. Not bad. Not bad at all. Right, we're at 10 minutes 30. So what I'm going to do is, let's just adjust it a bit more. I don't know what, it might be better to try and balance it. Take off the, take that off actually, and now let's see if we can push it a bit more. Take it over, sometimes taking it over helps. Yep, I think that's fine. 11 minutes, that's fine. Save exactly as seen. So there we go, we've saved that one. Again, so let's pause it, clear it, pause it. I need to write a sequencer. You can write a little program in the sequencer in SharpCap that allows me just to change between the modes, so I don't have to keep on doing that. So let's get rid of the live stack, and let's take us back to second exposure, and we'll do an automatic stretch. And we can still see the core of the galaxy here and the core of the other galaxy, I think, which is there. So we've seen that one. I think it might be, if I switch this back to it, it might be worth going for. There's the Sunflower galaxy down here, which might be worth going for. Let's have a look. It's not quite as impressive as M51. It's not quite as impressive, but you know, so it's okay. So maybe we'll have a little trip over to the Sunflower galaxy. Let's change your caption while we slew across. So M63, also known as the Sunflower galaxy, is 29 million light years away, as it says here, and we're coming in hot, and it's right there. I can already see a little. I'm going to go for 6 seconds again, I think. Oops. Let's do a 6-second exposure and see what we get. Yep, so we can see it just about here. If I put on the old, we're slightly off. Should we move it? We'll move it a little bit to the right then, as it's seen on the screen. A bit more. We're only doing 4 times sidereal skips here, so I think that's good enough actually. When it settles down, we'll get rid of the reticle. Okay, so we've got M51. Let's change that to M63. Let's live stack that. Let's clear what was there and clear what was there. And let's do a auto stretch on this. I think what I'll do is I will filter on Shift W, but I'm going to take it up to Let's bring the red down to meet the green, make the blue come up to meet everyone, and there we go. Let's bring it this way a bit. Yeah, so we can start to see, let's make this look the same. We can start to see that we've got the central bright core, and then there's multiple arms coming off of this galaxy. And it's very hard to see, you might be able to see it. You see there's a kind of a misty pattern around here. In fact, why have I got that? Let's take that off as well. A misty, where you can see where the arms are going to start to appear if we wait long enough. But a very bright core. Let's have a little look what Wikipedia thinks about. Oh, did I not select the object? I thought I did. Oh, I didn't, did I? No. There you go. We see some professional shots as well. So yeah, 29.3 million light years. So within this picture that we're looking at right now, according to this, there are 400, or approximately 400 billion stars. Wow. That is quite good. Sorry, that was an understatement. That was an understatement. 400 billion is an awful lot of stars. So it's continuous spiral structure. Wow. And there's some pictures of it as well. Very good. Very good. And so now we're getting a little bit more fluffiness around here as we go. We've got 18 frame stacks so far, 108 seconds worth of data. We're throwing away some data here. And we threw away 2 because of brightness there. That was due to the fact that the stars seemed to change, were too high. Let's go back to the log. Yeah, FHM were too high. We're just doing this a dither now. Yeah, we are starting to see some structure in here. So we're seeing more detail, which is exactly what we want to see. I mean, we can try doing an unshot mask, see if that... well, no. Let's try a Viner. Deconvolution. No, I think I'm going to keep it clean. There was something down here. I don't know whether that's just a artifact of this. PGC 45992. That bit, there's a fluffy bit down here. I don't know if you can see it. So that's a magnitude 14.73 active galaxy. It doesn't tell me the distance. I think we'll just do a... There we go. I think this is slightly off because that is UGC 83. That's definitely, I think, UGC 8313. Let's do another place of... well, we're dithering colouring, so... let's see if that... see if this circle here jumps, the ellipse jumps onto here. Yeah, there you go. So we were slightly off on our plate solve. It used an old one. So now that ellipse is perfectly around here, and that's a 14.8. There's a 17 magnitude there. There's a 16.51 there. There's a 16.81 there. Trying to see if I can see any others. Oh, there's a 16.81 right there. You can definitely see the dot. In fact, if I zoom in a bit, you'll see what I mean. There we go. You can definitely see that there's a galaxy far away here. Oh, look at the structure we've got here now. We're starting to see the starts of the spiral arms coming out. Anything else? Oh, there's one up here. I'll drag that down. That's a 17.5. And there's a hint. There's a hint that there's something here, which is an 18 point, is that 18.0? Yeah, 18.0. It's very hard for you to see, but here there's a slight hint that there's one there as well. Let's come back out. In fact, let's not mess around. Let's go 50%. So quite a few galaxies there. And let's just zoom in, because when we zoomed in, there was definitely some structure there. Now, coming a bit closer. For 100%. If I hold down the shift key when I move these, it takes it gently rather than full beans. Darkens the image a bit more. A bit too much. Back off a bit. Let's see if we bring the mid-level in. No, we can't really see about there. Possibly is giving us the ultimate. So this is only 4 minutes worth of data so far. 43 frames have been stacked. So we're not, I mean, we're nowhere near. We're going to get a much better image and a less noisy image if we stack quite a few more here. Our colour balance is wrong. Let me just get that blue up a little bit. Ooh. Maybe I've got that blue up a bit too much. Let's just come out a little bit. Yeah, I mean it's looking okay. The Sunflower Galaxy, you can see why it's got this called the Sunflower with this big area here, and then all of these, you can imagine all of those petals of the sunflower coming up. Very good. Yeah. 5 minutes. I might take a little snapshot there just to see if exactly it's seen. Yeah, it's impressive, isn't it? 29 million light years away, so slightly nearer than the Whirlpool, which we were at a minute ago, but still, that light left 29 million years ago. Extraordinary. And of course space, I suppose, has been expanding as well since then, so interesting. Yeah, you can really see some of the structure. Let's zoom on this one. So we've got these stars here. Definitely got, it's got 3 blobs along here. And there seems to be an area up there, which I think is that area there. There's definitely something over here. It's kind of H2 regions over here, which I think I can just see about here. So yeah, that's working quite well. But as you see, because it's dithering, I'm not seeing any walking noise. I'm not seeing any lines following the rotation of the thing. So usually you'd see like lines following the rotation of the field, and because I'm dithering, I don't see that. And the hot pixel removal is getting rid of, amazingly enough, the hot pixels. And the gradient removal is, well, we don't know, but it's, let's say it's doing its job as well. Let's come out, see the whole thing. darken it down a bit. No. Balance it that way a bit. It's lost a bit of its punch, hasn't it? I think I've done that now. But we're still we're over 125% now. But we can see that there's definitely some dark bits, some structure to this. That there's all these arms are just flying around it. And you see there's a kind of an extension bit up here as well, which is good. We're just going to take a snapshot of that. And we're going to pause it. We'll come out of live stack. We will go down to our 1 second quick pick again and do an auto stretch on that and make it back to where it was. I wonder if we've got some clouds coming across. I wonder. We've seen M3, haven't we? Let's try M53 because it's right there. It's another globular. There's an interesting thing about M53 and NGC5053 actually. So M53, if I select, that's okay, and select that one, and we're slew to M53. Let's see if we've got some clouds. Because I don't see any stars when we're slewing. Oh. I think we've got clouds. Yeah, we've definitely got clouds. Ooh. We look outside. What I'm going to do instead then is we're going to slew across to M5. And let's see if we move further away. If we move further to the south, whether we're going to see... Oh, we see stars now, so that's encouraging. Not as... No, it's very bright, like we are seeing stars. We are seeing clouds. Yeah, and it's not there, so we're pretty sure we've on our course, I think. What we're going to do, I'll just try one more time. I'll go up to M13, which is another bright globular cluster. Globular clusters are great doing moon, bright skies, because they're so bright. So, I mean, they do shine through high cloud as well, but we are getting gaps in this cloud by the looks of it. Let's see if we've got M13. Yeah, there's M13 there. Another globular cluster. Oh yeah, I went too far. Well, there's M13. I'm 100% sure this is a... Let's go for a 4-second exposure and see what we get. Oh, we've got to do M13, wasn't it? We were doing. Oh no, it's gone. Yeah, we've got lots of clouds. So I think at that point in time, we say that clouds stop play. So thank you for joining. That's